Let's understand device tree overlays. First of all, let's understand what exactly is a device tree overlay. Device tree overlays are device tree patches which are used to patch or modify the existing main device tree blob. Let's take an example to understand this. Let's say you have the BeagleBone Black board. How do you represent its hardware topology? By using its device tree blob. So the device tree blob is AM335X Bone Black DTB. This is a board specific. This explains the hardware topology of the board. Let's say you want to connect a cape, let's say LCD cape. The main DTB doesn't include the hardware details such as device nodes, properties, pin configurations to configure this cape. This file doesn't contain the hardware configuration of this cape. But to use this cape with BeagleBone Black hardware, you need those device tree modifications. There are two ways you can include the device nodes for the cape device in the main DTB. The first one is you can edit the main DTB itself. This is not recommended. Why? Because the main DTB is board specific. You should not edit this to include the details of this cape, because this DTB may be used by some other project which doesn't include this cape. That's why editing the main DTB is a bad idea to include the properties of the cape device. So the second method is overlays. That means you create a patch for that cape which overlays the main DTB. This is actually the recommended method. That means you write one more device tree source file where you include the details of your cape, and then you patch that file with the main DTB. What are the uses of overlays? First one could be to support and manage hardware configuration, that is properties, nodes, pin configurations of various capes of the board. So to alter the properties of already existing device nodes of the main DTB. Overlays approach maintains modularity and makes capes management easier. For example, what you can do here is you can create a separate DTS file for this cape. This we can call it as overlay source file. Then you can compile this file independently to generate the device tree blob. Here .dtbo is an extension we use to represent binary of an overlay, DTBO. DTBO indicates that this is an overlay which should be used with this LCD. So now let's understand overlay DTS format. The best place to understand this is the device tree documentation. So you can just go to the Linux source tree, go under documentation and go under device tree, and here overlay nodes.txt. I am referring to the same documentation here, and here it is, the overlay DTS format. This is the syntax you have to follow. First of all, the overlay is written in terms of fragments. This is a fragment 0 and this is a fragment 1. So your overlay file can contain multiple fragments. So the fragment is actually an area where you mention the changes which is going to happen in the main DTS file. This also refers to the first child node of the overlay file. This is the second child node of the device tree overlay. Once you write the fragment, so inside that you have to mention the target. So that means a target device node which you are going to modify. Basically you can use a absolute path here. So this is not recommended actually. I would suggest you to use this one, p handle. So just mention the p handle, something like an address of a device node. So this is a p handle target of the overlay. After that So you have to mention the changes, what and all you are going to do to this target inside the symbol called __ overlay __. This is a change which is going to happen in the target. So here you can include any properties, or you can change any properties of the target, or you can add more child nodes, something like that. So your project specific changes you can mention. Only these changes is going to take effect on the target. If you mention something above this overlay symbol, then that is ignored actually. Likewise, if you mention anything above these fragments, then those are ignored. So like that, you can create multiple fragments to modify multiple targets. Let's see one example. Here there is a main file. So this is board.dts. It's a main file, main DTS file, and let's say it has one node here, OCP, and this OCP has one child node, that is the I2C 0 controller. This is the on-chip peripheral of the SoC. Now you have to add a support for the RTC. So now let's say this RTC is connected to the I2C bus, which is governed by the I2C 0 controller. That means I2C 0 controller is a parent here, and RTC is a child. You can visualize through a parent and child relationship. That's why the RTC.dts, which is an overlay, is written something like this. First of all, here one fragment is created, and the target is I2C 0. This is actually a P handle. And after that, these are the changes. First of all, this I2C 0 controller node is activated. Its default state is actually disabled. Since this RTC is going to use that, its status is updated to OK. That means this device node is activated first, and after that this child node entry has been added, because RTC is a child of I2C 0 controller, and this is a device node of the RTC. After that, you just close the overlay and just close the fragment. When you patch this overlay to this DTS, you get this one. So finally it looks something like this. Board DTS plus RTC DTS, it looks something like this. Here you see a status is updated to OK, and a new child has been added. I hope you get some idea about writing the overlay. In the next lecture, we are going to write an overlay to modify some of the properties of our PC dev, and we'll take up that exercise in the next lecture. So now let's do one exercise. Write a device tree overlay to disable or modify PC dev device nodes from the main DTS file. These are the steps we'll be following. So the first step will be create a device tree overlay file and add fragments to modify the target device nodes. And after that, compile the device tree overlay file to generate .dtbo file, that is device tree overlay binary. Once we get the .dtbo file, then we are going to take the help of U-boot to load that DTBO file during board startup, because those are overlay files. All the overlay files should be loaded at the boot time to apply the changes to the main DTB file. That's why it's always better to load the overlays at the boot time, and we can take the help of U-boot to do that, because the latest U-boot actually supports the device tree binary and device tree overlay binary management. That's why we may have to use a newer version of U-boot, because throughout this course we are actually using a U-boot which is quite old. That actually is a version released in 2017, So now we actually want a U-boot which supports device tree management. That's why we'll install the newer version of U-boot. No problem, I will guide you through those steps. Let's do this exercise. Now first let's get into our DTS folder. Here let's open AM335X bone black LDD course.dtsi. Here let's do some changes here. First of all, let's assign a label to all these device nodes. I would call this as PCDAV0, and because we need to address these nodes, isn't it, from the overlay, that's why I'm giving the label PCDAV1. And after that, you see all these nodes are actually enabled by default. So whether a node is enabled or disabled is decided by the status property of the device node. So in this device tree file, all these nodes are enabled by default. You see in the previous exercise when we loaded the driver, there was the match between driver and the device node, and our probe function was executed for 4 times. So first of all these 4 device nodes are enabled by default. Whether a device node is enabled or disabled is decided by the status property. If the status property is absent, then it means that the device is enabled by default. That means that device node is enabled by default. So if you want to understand more about status property, then you can refer to the device tree specification. So here just go to the standard properties, and here it is, status property. And the status property indicates the operational status of a device. So values will be OK, disabled, and these things. Okay. Basically, it's a string property. You can use these strings as values. We'll be using these two, OK and disabled, which is pretty much sufficient. OK indicates the device is operational, and disabled indicates the device is not presently operational. So if the status property is disabled for a device node, then the probe function of the driver will not get called for that particular device node, even if there is a match between compatible strings. That's why this disabled value is used to turn off all the unused device nodes in a device tree. Otherwise, unnecessarily probe function will get invoked for all the device nodes, and it will consume lots of hardware as well as software resources like memories and pins, etc. That's why if you just check the upper level device tree include files, you see most probably most of the on-chip peripherals are actually disabled by default. You have to enable it if you are using that by using device tree overlays or by overriding those device nodes in the device tree file. So now let's save and exit this. Let's get into the custom drivers folder. Let me create one folder, overlays. Now let's create the first overlays. I will call it as PCDAV0.dts, and let's edit this. First of all, let's give the tokens. So you have to use these tokens. This actually indicates the DTS file version, and this indicates it's a plugin or an overlay. /DTS v1 plugin, and after that let's create a root node. After that, let's create the fragments. Fragment 0, and here let's terminate the fragment, and the target is equal to, let's disable PCDAV0 and 1. Let's target the PCDAV0 with its label, and __ overlay. Let's end the overlay here. This is actually the fragment. Here let me use status is equal to disabled. So that's the only change I would like to make here, and let me copy this Let me copy multiple times, and this is fragment 1. I would like to target PCDev1, status is equal to disabled, and for PCDev3 I would like to change one of the property. So let's check PCDev3. Let's save and exit. Let me change the size and device serial number. I would like to copy these two. Let me paste here, and let me make it as 1048, and let's change this to something else. PCDev 4 XXXXX, something like that. After that, so just give proper semicolons to terminate the body here. Overlay must be closed. This is a fragment which is closed. This is okay, and this is fragment number 2. Actually, these labels may confuse. So what I like to do is, let me change this to PCDev1. This is 1, 2, 3, and 4. Please make these changes because I would like to keep the node name and label name similar. Here, this is the first node is disabled, second node is also disabled, third node is not disabled, only properties have been changed, and the fourth node is not touched. Let's save and exit this. Now let's compile this overlay. To compile this, we are going to use a device tree compiler, DTC. Just type DTC, and if it is installed, then it will work, but if it is not found, then we have to run this command, sudo apt install device tree compiler. Let me run that. So it is installing device tree compiler. Just run man DTC. Here it is how to use this device tree compiler. Basically, you have to mention what is the output file format, whether you want DTS, DTB, or ASM, and then output file you have to mention. After that, input format, it could be DTS, something like that. So very simple to use. So now we created the overlay file. Let's see how to compile this. Let's use the DTC command, DTC hyphen capital O. This actually defines the output type, that is DTB, and output file name hyphen small o, and let me give the name PCDev0.dtbo. And after that, the input file is DTS, and here you also must define the input file type, whether it is DTS, DTB, or something else. So hyphen I, capital I, DTS. So this is the input file type, output file type, output file, and input file. Here you also use one more symbol, hyphen et. So this is actually required, otherwise the patching may not be successful because this creates some internal symbol table. That's why make sure that you use this and hit enter. Now you get these warnings. These warnings are actually harmless, so you can proceed, no problem. So ls, here it is, DTBO is formed, and now this DTBO we have to keep in our root file system, and we have to instruct the U-boot to pick that DTBO and apply to the main DTB during system startup. That's why let's connect the board and transfer this DTBO to the root file system of our board. So I'm going to connect my BeagleBone Black hardware. Let me log in. Let's send this file scp pcdev.dtbo Debian at 192.168.7.2 home Debian drivers. We just transfer that. Now let's take that and let's keep this in lib firmware, because we usually keep all the DTBOs in this folder lib firmware. So you can see that in the lib firmware you see already there are lots of DTBOs. This is actually our file. So these are some other files which I was experimenting with. So this is a file. Okay, since we have modified this main DTS file, it should be recompiled and the DTB must be transferred to the board. Let's do that. Let's get back to the Linux source directory and you have to run make, isn't it? So the command should be sudo make arch is equal to arm cross compile, the cross compiler, and the file name should be am335x boneblack.dtb. Hit enter and we created the DTB and this must be transferred. Let me go inside one of my project and in the make file we have that command copy DTB. Let's execute this. So we just transferred that file to the board. So we actually copied the new DTB. Now this needs to be transferred to the boot partition of the SD card. That's why you have to again mount that partition and you have to copy. For that I have written a small script. So it just mounts the device to some mount point and then copies and then runs sync. I'll just run this script. I copied the device tree binary to the root partition. Now the U-boot should pick that DTBO and it should apply that to the main DTB. But as I said in the previous lecture, we are actually using older version of U-boot which doesn't support device tree overlay management. That's why we have to install the newer version of U-boot. So let's do that. So now let's go to the U-boot repository. You have to go to this link. So the link I have given in the resource section of this video. Here you can go to the current source code which is hosted in the Git repository. Just click over here. And after that here you can change this master to pick 201904. Select this. I have tested with this and it works, and feel free to pick newer versions, no problem. After that go here and download this source code. You can download this as zip and extract it, and I'll see you in the next lecture. Hey, welcome back to the lecture. So I'm in the source directory here and I actually just extracted this. Now we have to configure this U-boot and we have to build this to generate the U-boot image. Let's get into the U-boot. If you go inside configs here, so you see there are lots of configuration files related to different hardware. For BeagleBone, you don't see any config file actually. So you have to use this config file. You have to use TI's AM335X evaluation boards configuration file. That is AM335X EVM defconfig. So this we have to use as a configuration file. Let's go back to this directory and here make arch is equal to arm. Just apply this defconfig. So the .config is generated and you can run menu config here. So if you want to change any configuration of the U-boot, so here you can just go to this delay in seconds before automatically booting option. Increase this to 5 because this will give you some time to stop the U-boot at the command prompt. And that's the only change I would like to make. So just exit this. Do you wish to save your new configuration? Press yes here, and after that you have to just cross compile this. Cross compile is equal to ARM Linux GNU EABI HF hyphen. You need not to mention any file name here, the output file name. So there seems to be some problem. GNU EABI HF, that's correct. It will take some time, please be patient. So the compilation is over, and here is the MLO generated, and we also generated uboot.img. that's the U-boot image. Just do ls here, and you see here uboot.img. this is our U-boot image, and you also generated MLO. These two needs to be transferred to our boot partition. Now first let's send these binaries to the board using SCP. I'll just use SCP MLO and uboot.img. Let's send this to our board. Transferred. Let's get into the board, and let's take sudo permission first. After that, let's mount the root partition, that is dev mmc block 0 p1. The mount point is mnt, so it is mounted, and let's go to the mount, and here it is. This is our older image, so take a backup of that if you want. And this is MLO. Anyway, these are pre-built images, so you may be having this in your system, isn't it? So if you want, you can take the backup of this, because we are going to override this. Let's first copy MLO, home, Debian, drivers, MLO, and after that uboot, sync. So now we updated MLO and uboot.img. So now let's see whether our board boots or not with a new U-boot. Let's just reboot. Here it is. The U-boot is updated. It boots, no problem. So complete up to here. And in the next lecture, let's see how to use this U-boot to apply our DTBO to the DTB. I'll see you in the next lecture. Hey, welcome back to the lecture. So far we have completed a few steps in this exercise. So now let me recap those steps. First thing was we actually edited our main DTS file, and after that we compiled that, and we now stored the AM335X bone black.dtb into the boot partition of the SD card. Second thing what we did was we wrote an overlay file and we compiled it, and then we stored that compiled overlay file, that is .dtbo file, in the root file system's lib firmware location. And after that we also updated our U-boot to newer version, and now we have to use a few U-boot commands to manipulate the DTBO. Now we have to take the help of U-boot to apply that DTBO to the DTB. So that's why we have to now get into the U-boot command prompt. Here this is a board. I'm just going to reboot, and I'm going to stop at the U-boot command prompt. So it is rebooting, and now you see here U-boot is running. I'm going to press any key. This is a U-boot command prompt. Here we should run few commands. U-boot overlay manipulating commands you can get from the U-boot documentation. So for that, let's go to the U-boot documentation. Go to the U-boot source here, go to doc and open readme FDT overlays. So here you find the section manually loading and applying overlays. We are going to follow these steps. First of all, we have to set these environmental variables, so with some addresses. This actually carries the address where we are going to store our main DTB. So that's what we call as base device tree blob, and this is the address where we are going to load the overlay, that is .dtbo. Let's run these commands. This command, what it does is it just sets this variable to this value. Let's do that. I'm going to copy this and paste it on the U-boot command prompt. So it is actually not recommended to paste, copy and paste. It's better if you type it, but to save time I just copy and paste, hit enter. After that, this one, paste here, and after that load the base blob and overlay blobs. That means you have to now load the .dtb to this address and overlay to this address. For that, let's use the load command. Load from MMC, load MMC, device type, that is MMC. Then you have to mention the boot partition. Let's do that. Boot partition is MMC 0:1, the first partition. So MMC 0 is our SD card and first partition, space. After that, the location, what you set here. Let's do that. $FDT_ADDR, and after that the main blob. Let's do that. That is AM335X -bone black.dtb. Here you see these many bytes have been copied to this location, and after that the same thing you have to do for overlay. Load MMC 0:1. So the address must be FDTOV ADDR. Oh, sorry, I did a mistake here. No problem. I just did a mistake over here. Let's do this again. Load MMC 0:1 FDTOV ADDR, your overlay file, that is in lib firmware, and the name is pcdev0.dtbo. Here you see there's a problem. It actually printed these many bytes red, right? But this command is not printing that information. That means this is a wrong command. The problem was this one. Our DTBO is in partition 2, that is in the root file system, 0:2. That's the correct command. Now you can see that the DTBO is copied into this location. Let's move forward. Set it as the working FDT tree. Set this address as working FDT location. So that's why you have to run this command. This command is actually FDT space ADDR. Somehow the space is missing here. This is a wrong command actually. So the correct command is FDT ADDR $FDT ADDR. That's correct. You have to resize this address because you are going to populate DTBOs into this location. So that's why you have to resize this location, so by some amount. Since we have got only one DTBO, this much amount is not required actually, but that's okay. We can just run this command. And after that, now you are ready to apply the overlay. Just run this command, fdt apply the overlay from this location into the active location, that is this one. Let's run this command. We applied the DTBO into DTB. So now the final modified DTB is now at this location. Now what you do is, let's exit this. Let's go to our workspace, go to downloads and go to pre-built images, go to SD boot. Here just open uenv.txt. So here we have to manually copy this and paste it onto the U-boot prompt, because now we are going to boot Linux manually. Let's just copy this from here, setdnv, bootox, console, everything. Just copy this and paste here, hit enter. So now execute the bootm command. For the boot command, you have to mention the address of the Linux image here, and here you have to mention the address of the device tree. We actually have the active address of the device tree, but we don't have active address for the Linux image. Let's load the Linux image into this location. Let's get back to the U-boot and run load mmc 0:1 $load addr uimage. I'm actually loading uimage from SD card into this location. And now let's run bootm command. First you have to mention the address where you have stored the Linux image, that is this address, load addr hyphen. Now you have to mention the fdt address, fdt addr. Let's hit enter. Kernel is booting. So the boot was successful. Now let's log in. Let's get inside sys, devices and platform. This is a place to check all the platform devices. Just do ls, and you see here only 2 devices have instantiated. You don't see PCDAV 1 and 2 because we disabled that through our device tree overlay. Load the driver. Now you see here, this was the change we did to the device tree through the device tree overlay. You can see those changes reflecting here. That's about device tree overlay, and we'll be using this method for our other exercises as well, which are based on device tree. And in this exercise, we actually manually entered all the U-boot commands to manipulate the DTB and the DTBO. Instead of doing that, we can put all the commands in the uenv.txt and we can automate things. We can add few commands to the uenv.txt to load multiple overlays at the boot time. So I will take up that in the next lecture. Make sure that you complete up to here, and I'll see you in the next lecture. to the lecture. So in the previous lecture we tested the device tree overlay and it was a tedious process. We entered all the U-boot commands manually. In this lecture, so let's automate that using uenv.txt, and we can also improve our uenv.txt to include multiple device tree overlays. For that, go to this folder in the downloads and just do ls. You see here uenv.txt and just make a copy of that. We are going to edit this. I am going to copy this as dtbo.txt. Let's edit uenv.dtbo.txt. Here these are the boot arguments what is being used in this SD card boot. Let's also open the U-boot documentation. Go to the U-boot documentation. This is a U-boot documentation. Now we have to include all these commands in the uenv.txt. These commands are actually some environment variable setup. Let's do one thing. In this file, I'm going to create one variable called overlay env setup, and I'm going to equate this variable to few commands. First command would be this semicolon, and this will be the second command. So I just created one variable and equated that to these two commands. After that, these two commands are actually loading of device tree binaries. Let's create one more variable. I will call it as overlay or fdt load, something like that. I equate that to these commands. Copy that and paste here. We have to modify this. Dev type is, let's directly use MMC. Boot partition is 0:1, and this is FTP address, that's correct. This will be AM335X phone black DTB, and after that give a semicolon. Let's write the second command. So let's copy this, paste here, and this will be this address fptovAddr, and this will be lib firmware. Or I can do one thing, I can just define one more variable here, dtbo path, something like that, is equal to lib firmware, and here this will be $, dtbo path, and the name of the DTBO, that is PCDev0. But what if our project contains multiple DTBOs? Then I think this won't help, so I'm going to remove that. We have to keep that in a loop. Let's think about that later. FDT load, so let's end this variable here itself, and after that let's take care of these commands. I call it as fdtcmd, so I create one more command here and I encode these commands there. The first command, this is fdt space addr, and this is resize semicolon, and this is apply. After that, let's create one more variable. I call it as overlays is equal to, so I will use this variable to list all my DTBO's name. Currently I have got only one DTBO, PCDev0.DTBO. If you have got one more DTBO, then mention that here itself, PCDev 1.dtb or something like that. This variable actually holds multiple values. A value is nothing but name of the DTBO file. Currently I have got only one. So here I am going to create one more variable. Let me call it as fdt overlay load. Let me call something like that. This variable will hold the command to load the different overlays in a loop. Let's use a for loop for I in overlays. So for every item in the value of overlays, in the value of means you have to use the $sign here, give a semicolon. For every item in this value you have to execute load mmc 0:1. So you have to load into fdt ov addr from $sign DTBO path. So for every item I, so you have to use I here, $sign I. I hope this makes sense. This variable set to this command. This is a for loop actually. For every I which is a valid item in this list, you can consider it as a list. This command actually executes. So if this is true, then this command executes. And after that you can give a semicolon here, and in a loop you have to execute apply. That's why apply I have to remove from here. Let me remove apply from here and let me keep that here. fdt apply fdt ov addr, correct, and just terminate that with a semicolon, and after that just write the command done to end the for loop. These two commands will execute in loop. Let me also keep one echo command here. You can write something like this: do echo applying overlays, something like that, and end this command with a semicolon. So there are three commands in a for loop actually. Let's create one more variable called DTB, that is equal to am335x bone black.dtb. Let's replace this with that variable name. And after that comes the boot settings, and after that comes this one. When U-boot executes this command executes run mmc boot. The command which is there inside this variable will get executed. That is, these commands will get executed. So we are just writing booting from micro SD card. But before that, we have to complete our FDT things. What we can do now here is, so mmc boot, here what you do, first run this one, overlay environment setup. Just run that. Run this variable ov env setup. So first these two commands will get executed, and after that let's execute this one, fdt load. Run fdt load, and after that we want to execute fdt command. Run fdt cmd semicolon. After that we want to execute this one, fdt ov load. Let's do that. Run fdt ov load. After that, once this is done, the FDT thing is over actually, and after that echo booting from micro SD card, that's okay. So, and after that this actually executes, that is U image is transferred to this location, that's okay, but we have to remove this. This FDT thing is over, that's why we have to remove that. So after that run boot settings, and boot settings will get executed, and after that there is a bootem command. So everything looks fine now. When U-boot reads this unv.txt, it will apply all these environment variable setup to its environment variable, and then the U-boot executes this command. That actually triggers all our command execution. First, this will be triggered, so this will trigger this one, this one, this one, and like that. So now let's get into our overlays folder here, and let me create one more overlay file. I'll be calling this as pcdev1, and let me edit this file. So I'm going to add one more fragment. I'm going to remove all these things. So I'm going to disable the pcdev3 with this fragment. Let's compile this using DTC. and just terminate that with a semicolon, and after that just write the command done to end the for loop. These two commands will execute in loop. Let me also keep one echo command here. You can write something like this: do echo applying overlays, something like that, and end this command with a semicolon. So there are three commands in a for loop actually. Let's create one more variable called dtb, that is equal to am335x bone black dot dtb. Let's replace this with that variable name. And after that comes the boot settings, and after that comes this one. When U-boot executes this command executes run mmc boot. The command which is there inside this variable will get executed. That is, these commands will get executed. So we are just writing booting from micro SD card. But before that, we have to complete our FDT things. What we can do now here is, so mmc boot, here what you do, first run this one, overlay environment setup. Just run that. Run this variable ov-env setup. So first these two commands will get executed, and after that let's execute this one, fdt load. Run fdt load, and after that we want to execute fdt command. Run fdt cmd semicolon. After that we want to execute this one, fdt ov load. Let's do that. Run fdt ov load. After that, once this is done, the fdt thing is over actually, and after that echo booting from micro SD card, that's okay. So, and after that this actually executes, that is U image is transferred to this location, that's okay. But we have to remove this FTT thing is over, that's why we have to remove that. So after that run boot settings, and boot settings will get executed, and after that there is a bootem command. So everything looks fine now. When U-boot reads this unv.txt, it will apply all these environment variable setup to its environment variable, and then the U-boot executes this command. That actually triggers all our command execution. First this will be triggered, so this will trigger this one, this one, this one, and like that. So now let's get into our overlays folder here, and let me create one more overlay file. I'll be calling this as pcdev1, and let me edit this file. So I'm going to add one more fragment. I'm going to remove all these things. So I'm going to disable the pcdev3 with this fragment. Let's compile this using DTC. And this name must be mentioned in the uenv.txt. Let's get into the downloads pre-built images, sdboot, and let's open uenv.dtbo.txt. So here in the overlays variable, just give a space here and mention the second DTBO. Like that, you have to mention n number of DTBOs. Let's get into the overlays folder here. We need to transfer this DTBO into the libfirmware folder of the board. So let's do that. Let's do scp pcdev1.dtbo, and now we have to replace the previous uenv.txt with a new uenv.txt what we just wrote. So let's get into the download folder once again, and let's transfer this uenv.txt to the board. Let me again do scp here. So uenv.dtbo. Let's get into the board. So this is a board, and let's go to drivers. Now you have to keep this uenv.txt into the boot partition of the SD card. That's why let's mount the root partition mmc blk0p1 mount and copy this file as uenv.txt. Sync. Let's reboot. U-boot is running here. It is going to apply both the overlays, and here it is. So applying the first overlay here, then it is applying the next overlay. So the kernel is booting now. Let's log in. So let's go to sys devices platform. Now you see only one device appears. PCDEV1 and 2 disabled using first DTBO, and the second overlay is actually disabled the third device. So that's why there is only one device is appearing. Now you can load the driver. You see there is only one device instantiation. So the probe function actually ran for only one time. That's about device tree overlays. So we'll be using device tree and device tree overlays for future exercises as well. I believe you get some idea about device tree and device tree overlay. And with that note, I would like to end this section on device tree overlays. From next section onwards, we are going to explore about the Linux device model and dealing with the sysfs and its attributes. I'll see you in the next lecture.